Let us begin our journey in the vast darkness of space, where light travels for billions of years before reaching our eyes. Close your eyes and imagine the universe as it was, long before anything we know existed. In the beginning, there was only hydrogen and helium, the simplest elements, drifting through the cosmic void. These primordial clouds floated in darkness for millions of years, slowly gathering together under the gentle pull of gravity. As they collected, they grew denser, and within these nurseries, the first stars ignited, burning bright against the emptiness. These ancient stars lived fast and died young, exploding in magnificent supernovae that scattered heavier elements across the universe. Carbon, oxygen, nitrogen, iron, all the elements that would one day form planets, trees, and even your brain, were born in the hearts of dying stars. From this stellar dust, galaxies began to take shape. Our own Milky Way galaxy contains between 100 and 400 billion stars, each one a sun unto itself, many with their own families of planets orbiting in endless dance. The Milky Way stretches across 100,000 light-years of space, so vast that light itself, traveling at 186,000 miles per second, would take 100,000 years to cross from one edge to the other. Yet despite containing all these billions of stars, galaxies are mostly empty space. If you could stand within a galaxy, the distances between stars would feel impossibly lonely, with light years of darkness separating each brilliant point of light. At the center of our galaxy lies something mysterious and powerful. A supermassive black hole, named Sagittarius A*, sits quietly at the galactic heart, containing the mass of about 4 million suns compressed into a region smaller than our solar system. This cosmic anchor holds our entire galaxy together, its gravity gently orchestrating the motion of billions of stars in their slow, elegant orbits. Our own sun takes approximately 230 million years to complete just one orbit around the galactic center. Dinosaurs walked the Earth the last time we were at this point in our cosmic journey. Galaxies come in many forms, each one a unique sculpture of light and matter. Spiral galaxies like our Milky Way spin gracefully, their arms trailing through space like cosmic whirlpools, glowing with the blue light of young stars being born in clouds of gas and dust. Elliptical galaxies appear as smooth, featureless orbs of older, reddish stars, having long ago used up their star-forming material. And then there are irregular galaxies, chaotic and asymmetric, often the result of cosmic collisions that have twisted their structures into strange, beautiful shapes. Our neighboring galaxy, Andromeda, is approaching us at about 250,000 miles per hour. In approximately 4.5 billion years, these two great islands of stars will merge in a slow-motion collision that will take millions of years to complete. Despite containing hundreds of billions of stars each, the vast distances between individual stars mean that actual stellar collisions will be extremely rare. Instead, the two galaxies will pass through each other like ghosts, their structures eventually blending to form a new elliptical galaxy that astronomers have already nicknamed Milkomeda. Now, let your mind drift from the cosmic scale to something much closer, yet equally mysterious. Inside your skull, weighing about 3 pounds, sits perhaps the most complex structure in the known universe, your brain. Your brain contains approximately 86 billion neurons, nearly as many nerve cells as there are stars in the Milky Way galaxy. Each of these neurons can form connections, called synapses, with thousands of other neurons. In total, your brain houses roughly 100 trillion synaptic connections, creating a network of such staggering complexity that we are only beginning to understand how it works. If you were to count these synapses, one per second, it would take you more than 3 million years to count them all. The resemblance between galaxies and neural networks is striking. When astronomers map the large-scale structure of the universe, showing how galaxies cluster along vast filaments of dark matter with enormous voids between them, the patterns look remarkably similar to images of neurons and their branching connections. This cosmic web of galaxies spans billions of light years, yet its structure mirrors the neural web inside your skull. The universe seems to organize itself in similar patterns at vastly different scales, from the microscopic to the cosmic. Just as galaxies are mostly empty space, your brain is surprisingly sparse. Neurons make up only about 10% of the brain's cells. The other 90% consists of glial cells, which support and protect neurons, and a great deal of empty space between structures. The brain is about 75% water, soft and delicate, protected within its bony vault. Yet from this fragile, watery organ emerges everything you are, your memories, your dreams, your sense of self. Information travels through your brain at speeds up to 268 miles per hour along the fastest nerve fibers, though most signals move more slowly. This might seem fast, but it's nothing compared to the speed of light traveling between stars. Yet what your brain accomplishes with its relatively slow, electrochemical signals is extraordinary. Every thought, every sensation, every memory is encoded in the patterns of neurons firing in coordinated sequences, much like stars in a galaxy moving in their ancient orbits, but on a timescale of milliseconds rather than millions of years. The brain consumes about 20% of your body's energy, despite making up only 2% of your body weight. It's an expensive organ to operate, requiring a constant supply of oxygen and glucose to keep its billions of neurons firing. Even as you sleep, your brain remains remarkably active, processing the day's experiences, consolidating memories, and maintaining all the unconscious systems that keep you alive. In deep sleep, your brain activity shows slow, synchronized waves that sweep across its surface like ocean tides, very different from the rapid, chaotic patterns of waking thought. When you learn something new, your brain physically changes. New synaptic connections form between neurons, and existing connections strengthen or weaken. This neuroplasticity means your brain is never quite the same from one moment to the next. Each experience, each thought, each memory alters the structure of your neural network in subtle ways. In a sense, you are constantly being rewired by your experiences, just as galaxies are slowly reshaped by their gravitational interactions with one another over cosmic time. The brain's ability to recognize patterns is one of its most remarkable features. From billions of neurons firing in complex patterns, your brain extracts meaning, recognizes faces, interprets language, and makes sense of the world. This pattern recognition extends to the cosmos as well. Humans have always seen patterns in the night sky, connecting stars into constellations, finding meaning in the movements of planets, seeking to understand our place in the universe. Both galaxies and brains emerge from simple rules playing out over vast scales. Galaxies form from the gravitational attraction of matter, following the laws of physics in a cosmic dance that began billions of years ago. Your brain develops from a single fertilized cell following genetic instructions, with neurons migrating to their positions, sending out axons and dendrites to find their partners, creating the intricate network that will become you. In both cases, complexity emerges from simplicity, and order arises from apparent chaos. Consider for a moment the concept of dark matter. About 85% of the matter in the universe is dark matter, invisible to our telescopes, detectable only through its gravitational effects on visible matter. It forms the scaffolding upon which galaxies are built, the invisible framework that holds the cosmic web together. In a similar way, much of what happens in your brain occurs below the level of consciousness. The vast majority of neural processing happens without your awareness. Your unconscious mind handles countless tasks, regulating your heartbeat and breathing, processing sensory information, maintaining balance, storing and retrieving memories. Like dark matter, this unconscious neural activity is invisible to direct observation but fundamentally shapes your conscious experience. The universe is approximately 13.8 billion years old. Our Sun and solar system formed about 4.6 billion years ago from the remnants of earlier generations of stars. Life on Earth emerged around 3.8 billion years ago, beginning as simple single-celled organisms. For billions of years, life remained microscopic. Then, in a relatively recent burst of evolutionary creativity, complex organisms appeared. Nervous systems evolved, and eventually, brains developed. The first simple nervous systems appeared in creatures like jellyfish around 600 million years ago, mere clusters of nerve cells that could coordinate basic responses. Over hundreds of millions of years, brains became more complex. Fish developed larger brains with distinct regions for different functions. When animals moved onto land, their brains expanded further to process new kinds of sensory information and coordinate more complex behaviors. Mammals evolved particularly large brains relative to their body size, with expanded regions for processing social information and forming complex memories. Then, very recently in cosmic terms, humans appeared. Modern humans, Homo sapiens, have existed for only about 300,000 years, less than a blink of an eye in cosmic time. Yet in this brief moment, human brains have developed the ability to understand their own origins, to peer back in time to the beginning of the universe, to understand the nature of galaxies, stars, and atoms. We are, in a very real sense, the universe becoming conscious of itself. The atoms in your body, forged in the nuclear furnaces of ancient stars, have come together in such a way as to form a structure capable of contemplating its own existence. The carbon in your cells, the oxygen you breathe, the calcium in your bones, all of these elements were created billions of years ago in stellar explosions. You are made of star stuff, as the astronomer Carl Sagan famously said. Your connection to the cosmos is not metaphorical but literal and physical. Galaxies evolve over billions of years. They form from clouds of gas, ignite with star formation, merge with other galaxies, and eventually, after many billions of years, will exhaust their star-forming fuel. The stars will age and die, and the galaxies will slowly fade. But in the meantime, they shine brilliantly, lighting up the darkness of space with the glow of billions of suns. Your brain, too, evolves and changes over your lifetime. In childhood, your brain forms new synaptic connections at an astonishing rate, building the neural networks that will support learning, memory, and thought. In adolescence, your brain undergoes a major reorganization, strengthening some connections while pruning away others that are rarely used. In adulthood, your brain continues to adapt and change, forming new memories, learning new skills, responding to new experiences. And in old age, like ancient stars, some neural connections fade, though others remain strong, carrying the memories of a lifetime. When you look at the night sky, photons that have traveled for years, decades, or even millions of years enter your eyes and strike your retina. These ancient photons trigger a cascade of chemical signals that travel along your optic nerve to your visual cortex at the back of your brain. There, in the darkness inside your skull, your brain reconstructs an image of the cosmos. You are not seeing the stars directly. You are experiencing a simulation created by your brain from the information carried by light. In a very real sense, everything you experience is a simulation created by your brain. The colors you see don't exist in the physical world. They are interpretations your brain creates from different wavelengths of electromagnetic radiation. The sounds you hear are your brain's interpretation of pressure waves in the air. Even your sense of self, the feeling that there is a you experiencing these sensations, is a construction of your brain, a useful fiction that allows you to navigate the world. Galaxies exist in something called the observable universe, the region of space from which light has had time to reach us since the Big Bang. The observable universe is a sphere about 93 billion light-years in diameter, containing an estimated 2 trillion galaxies. But the universe beyond what we can observe may be far larger, perhaps infinite. There may be regions of the universe so distant that their light will never reach us, entire galaxies and clusters of galaxies forever beyond our ability to observe. Similarly, there are aspects of your own brain that you can never directly observe. You cannot experience your own neural activity directly. You can only experience the results of that activity. The actual electrochemical processes happening in your neurons are forever hidden from your conscious awareness. You experience thoughts and feelings, but you cannot observe the mechanisms that produce them. In this way, both the cosmos and consciousness have limits to what can be known. Black holes represent one of the universe's deepest mysteries. These regions of space-time are so warped by gravity that nothing, not even light, can escape from within their event horizons. Information that falls into a black hole appears to be lost forever, creating a paradox that physicists are still working to resolve. Similarly, some aspects of consciousness remain deeply mysterious. How does the physical activity of neurons give rise to subjective experience? Why does it feel like something to be you? This is known as the hard problem of consciousness, and like the mysteries of black holes, it remains unsolved. Yet despite these mysteries, both galaxies and brains follow natural laws. Galaxies obey the laws of gravity and thermodynamics, playing out their cosmic ballet according to the rules written in the fabric of space-time. Brains obey the laws of chemistry and biology, with neurons communicating through neurotransmitters and electrical signals, following pathways shaped by evolution and experience. The expansion of the universe is accelerating. Driven by a mysterious force called dark energy, Galaxies are moving apart from each other at ever-increasing speeds. In the far future, billions of years from now, the universe will be a much lonelier place. Galaxies outside our local group will recede beyond the cosmic horizon, their light stretched into the infrared and eventually becoming undetectable. Future astronomers in that distant era will look out at a seemingly empty universe, with only the stars of their own merged galaxy visible against the darkness. Your brain, too, has its far future. As you age, some cognitive functions decline while others remain stable or even improve. Working memory and processing speed tend to slow with age, but wisdom, vocabulary, and emotional regulation often improve. The brain you have at 80 is not the same brain you had at 20, just as the universe of the far future will be vastly different from the universe today. But in this present moment, both the cosmos and your consciousness are vibrant and alive. Galaxies are forming stars, planets are orbiting their suns, and somewhere out there, perhaps on countless worlds, other conscious beings are looking up at their own night skies, wondering about their place in the universe. And here, now, your brain is processing these words, creating meaning from patterns of light and dark, connecting ideas, forming new memories, and continuing the ancient process of trying to understand the cosmos that gave birth to consciousness. There is a concept in physics called entanglement, where two particles can become correlated in such a way that the state of one instantly affects the state of the other, no matter how far apart they are. Einstein called it spooky action at a distance. In a sense, everything in the universe is entangled with everything else, not through quantum mechanics but through shared history. Every atom in your body was once part of the cloud of gas that formed our solar system. Before that, these atoms were scattered across the galaxy, perhaps part of different stars. And before that, they were created in the Big Bang that began everything. You are connected to the cosmos not just through the atoms you're made of, but through the very laws of physics that govern both your brain and the galaxies. The electromagnetic force that holds atoms together in your cells is the same force that causes stars to shine. The thermodynamics that governs the flow of energy in the universe also governs the flow of energy in your brain, with both systems constantly fighting against entropy, creating order from disorder, at least temporarily. Galaxies rotate with a stately grace that defies human timescales. Our Milky Way completes one rotation every 225 to 250 million years. From the perspective of the galaxy, the entire span of human history is less than 1,000th of a galactic year. The pyramids were built less than a cosmic eye blink ago. And yet, in that brief moment, human consciousness has emerged, evolved, and begun to comprehend the cosmos that contains it. Your brain cycles through different states much more rapidly. During waking hours, your neurons fire in complex, chaotic patterns as you process information, make decisions, and interact with the world. But in sleep, different patterns emerge. In slow-wave sleep, your neurons fire in synchronized waves, like a cosmic rhythm pulsing through your brain. In REM sleep, your brain becomes almost as active as when you're awake, creating the vivid, sometimes bizarre experiences we call dreams. Dreams remain mysterious, even to neuroscientists. Why does the brain create these internal simulations during sleep? One theory suggests that dreams help consolidate memories, integrating new experiences with old ones. Another suggests they help process emotions, allowing the brain to work through feelings in a safe, internal environment. Dreams might be the brain's way of maintaining its neural networks, keeping synapses active even when the body is at rest. In dreams, the normal rules don't apply. You can fly, visit impossible places, talk to people long gone. Time flows strangely. You can experience what seems like hours in just a few minutes of REM sleep. In this way, the dreaming brain creates its own universe, governed by its own laws, as free and strange as any galaxy. Both galaxies and brains are systems of organized complexity, structures that maintain themselves far from equilibrium. A galaxy maintains its structure through the balance between gravity, which pulls matter together, and the momentum of stars, which keeps them from collapsing into the center. Your brain maintains its structure through the constant activity of neurons, with signals flowing in carefully orchestrated patterns, regulated by feedback loops and homeostatic mechanisms. Both systems are also fragile in their own ways. Galaxies can be disrupted by close encounters with other galaxies, their structures warped and distorted by gravitational interactions. Your brain can be disrupted by injury, disease, or chemical imbalances, with even small changes in neural chemistry capable of profoundly altering consciousness, mood, and behavior. Yet both systems are also remarkably resilient. Galaxies can survive collisions and mergers, with their stars finding new orbits in the merged structure. Your brain can recover from injury through neuroplasticity, with surviving neurons forming new connections to compensate for damaged areas. Stroke patients can regain lost functions as their brains rewire themselves. Children with damaged brain regions can still develop relatively normally as other areas take over the functions of the damaged tissue. The study of galaxies and the study of the brain share similar challenges. Both are incredibly complex systems with many interacting parts. Both are difficult to observe directly. We can't see inside a black hole, and we can't directly observe the subjective experiences generated by neural activity. Both fields rely on indirect observation, careful measurement, and sophisticated models to understand their subjects. Astronomers use telescopes to collect light from distant galaxies, analyzing the spectrum of that light to determine what elements are present, how fast the galaxy is moving, and how far away it is. Neuroscientists use similar techniques, employing technologies like fMRI and PET scans to observe brain activity indirectly, measuring blood flow and metabolism as proxies for neural firing. Both fields are trying to understand complex systems through the fragments of information they can observe. In recent decades, both fields have made remarkable progress. Astronomers have discovered that the universe is not only expanding but accelerating, driven by dark energy. They've detected gravitational waves, ripples in space-time caused by colliding black holes and neutron stars, confirming predictions made by Einstein a century ago. They've found thousands of exoplanets orbiting other stars, and are beginning to characterize their atmospheres, searching for signs of life. Neuroscientists have mapped the connections between neurons in simple organisms like the roundworm C. elegans, whose nervous system contains just 302 neurons. They're working toward mapping the human connectome, the complete wiring diagram of the human brain. They've discovered that the brain is far more plastic than previously thought, capable of significant reorganization throughout life. They've identified specific neural circuits involved in memory, emotion, and decision-making, and are beginning to understand how disorders like depression, schizophrenia, and Alzheimer's disease arise from disruptions in these circuits. Both fields are also grappling with fundamental questions that remain unanswered. In cosmology, what is dark matter? What is dark energy? What happened in the first moments after the Big Bang? Is our universe one of many in a vast multiverse? In neuroscience, how does consciousness arise from neural activity? How are memories stored and retrieved? How does the brain generate creativity, insight, and self-awareness? These questions may seem very different, but they share a common theme. They are questions about how complexity emerges from simpler components, how order arises from chaos, how the universe gives rise to structure and pattern at every scale, from subatomic particles to galaxies, from molecules to minds. There is something profound about the fact that humans, tiny creatures on a small planet orbiting an average star in an ordinary galaxy, can understand so much about the cosmos. We are made of atoms that were forged in stars, organized by evolution into brains capable of comprehending their own origins. We can trace our history back to the beginning of the universe, understand the forces that shaped galaxies, and peer into the quantum realm that underlies all of reality. This ability to understand the universe is itself one of the universe's most remarkable features. For billions of years after the Big Bang, there was no consciousness anywhere in the universe, just matter and energy playing out the laws of physics in an unconscious cosmic dance. But eventually, on at least one planet, and perhaps on many others, matter organized itself into living systems, and those living systems developed nervous systems, and those nervous systems became complex enough to give rise to consciousness. Consciousness represents something genuinely new in the universe. With consciousness came the ability to experience, to suffer and enjoy, to remember and anticipate, to imagine things that don't exist and bring them into being. Through consciousness, the universe has developed the ability to reflect on itself, to study itself, to understand its own nature. You are part of this cosmic story. The atoms in your brain were created in stars that lived and died before our sun was born. The molecules in your cells were assembled through billions of years of evolution. The thoughts in your mind arise from patterns of neural activity that reflect both your unique experiences and the shared evolutionary heritage of all humans. You are a temporary arrangement of matter and energy, a brief eddy in the cosmic flow, but while you exist, you are the universe experiencing itself from one particular point of view. As you drift towards sleep, imagine your consciousness expanding, encompassing larger and larger scales. Feel yourself not just as a separate individual, but as part of the continuous web of cause and effect that connects you to everything else. The oxygen in your lungs was exhaled by plants and plankton. The energy in your cells came from the sun, created by nuclear fusion in its core. The patterns of thought in your brain reflect billions of years of evolutionary history, encoded in your genes and shaped by your experiences. Zoom out further. See the Earth from space, a blue and white marble suspended in the darkness. See the Sun and its family of planets, all orbiting in their ancient patterns. See the Milky Way, a spiral of stars wheeling slowly through space. See the local group of galaxies, bound together by gravity, island in the expanding void. See the cosmic web, galaxies strung along filaments of dark matter like dew on a spider's web, with vast empty spaces between. And now zoom back in. See your body, made of trillions of cells, each one a universe unto itself, with its own membrane, its own organelles, its own chemical processes. See your brain, with its billions of neurons firing in coordinated patterns, creating the experience of being you. See a single neuron, with its complex tree of dendrites reaching out to receive signals from thousands of other neurons, its axons stretching away to send signals to thousands more. At every scale, from the cosmic to the microscopic, the universe is organized into patterns, structures nested within structures, each level giving rise to new properties and possibilities that don't exist at smaller scales. Atoms combine to form molecules, molecules combine to form cells, cells combine to form organs, organs form organisms, organisms form societies, societies form civilizations. And civilizations, looking up at the stars, begin to understand the cosmos that gave rise to them. This is the great story of existence, the narrative that connects galaxies to brains, stars to consciousness, the simplest laws of physics to the most complex phenomena in the universe. It is a story still being written, with new chapters added every day as scientists make new discoveries, as minds grapple with new ideas, as consciousness continues to explore the universe of which it is a part. But for now, in this moment, it is enough to rest in the awareness of connection. You are not separate from the universe, you are an expression of it, one of the ways the universe experiences itself. Your thoughts are cosmic events, just as real and significant as the formation of galaxies, the fusion of atoms and stars, the expansion of space itself. As sleep approaches, let your awareness rest in this cosmic perspective. You are ancient and young, vast and small, separate and connected. You are made of stardust, animated by starlight, contemplating stars. You are a galaxy of neurons, firing in patterns as complex as any constellation, creating the inner universe of consciousness from the same laws that govern the outer universe of galaxies and light. Rest now, secure in your place in the cosmos, knowing that the universe that created you will continue its dance long after you wake. The stars will keep shining, the galaxies will keep turning, and consciousness will continue to emerge from the matter and energy of the universe, forever seeking to understand itself. From galaxies to brain, from cosmos to consciousness, from the vast to the small, from the ancient to the fleeting present moment, all is connected in the great web of existence. And in this web, you are both a single thread in the entire tapestry, both observer and observed, both question and answer. Let these thoughts carry you gently into sleep, where your brain will continue its ancient work, processing, connecting, dreaming, maintaining the miracle of consciousness that allows the universe to know itself. Rest well, child of stars. Rest well, cosmos in miniature. Rest well, consciousness, and dream of the infinite. the universe whispers its secrets in the language of light. Every photon tells a story, carrying information across the vast emptiness of space. When you observe a distant galaxy, you are not seeing it as it is now, but as it was millions or billions of years ago when the light you're seeing began its journey. The Andromeda Galaxy, our nearest large galactic neighbor, appears to us as it was 2.5 million years ago. We are seeing into the past simply by looking outward into space. Your brain also works with delays, though on much shorter timescales. When you touch something, the sensation doesn't reach your conscious awareness instantaneously. Signals from your fingertips must travel up nerves to your spinal cord and then to your brain, where they're processed and interpreted. This takes about 50 milliseconds. Similarly, when you see something, about 100 milliseconds pass before you become consciously aware of it. You are always experiencing the past, living in a world that your brain constructs from slightly outdated information, smoothing over the delays to create the seamless illusion of the present moment. Galaxies are surrounded by enormous halos of dark matter, extending far beyond the visible stars and gas. These dark matter halos can be 10 times larger than the galaxy itself, invisible cocoons that provide the gravitational scaffolding for galaxy formation and evolution. Within these halos, galaxies are just the bright centers, like glowing hearts within vast, invisible bodies. Your brain, too, is surrounded by protective layers. The skull provides physical protection, but there are also 3 membranes called the meninges that envelope the brain, and the cerebrospinal fluid that cushions it, absorbing shocks and providing nutrients. The blood-brain barrier carefully controls what substances can pass from your bloodstream into your brain tissue, protecting this delicate organ from toxins and pathogens. Your brain is as carefully shielded as any precious thing. In the space between galaxies, the intergalactic medium, there exists an incredibly thin gas, with densities of less than 1 atom per cubic meter. Yet even this near-perfect vacuum glows faintly with light, heated to temperatures of hundreds of thousands or even millions of degrees by the radiation from galaxies and the shock waves from exploding stars. This hot gas traces the cosmic web, revealing the large-scale structure of the universe. Between your neurons, in the synaptic clefts, neurotransmitters drift across gaps only 20 to 40 nanometers wide. These molecules carry signals from one neuron to the next, floating across the microscopic space in just a fraction of a millisecond. Different neurotransmitters create different effects. Glutamate excites neurons, making them more likely to fire. GABA inhibits them, making them less likely to fire. Dopamine is involved in reward and motivation, serotonin in mood regulation, acetylcholine in attention and memory. Your thoughts, emotions, and experiences all depend on the precise choreography of these molecular messengers. Some galaxies are active galactic nuclei, or AGN, where the supermassive black hole at the center is actively feeding on matter. As gas and dust spiral into these black holes, they heat up to millions of degrees, creating brilliant beacons of light that can outshine the entire galaxy. Some AGN produce jets of plasma that shoot out from the black hole's poles at nearly the speed of light, extending for millions of light years into intergalactic space. These jets can trigger star formation in distant regions or, conversely, heat up gas and suppress star formation. The black hole, though tiny compared to the galaxy, shapes the evolution of the entire system. Your brain also has central structures that exert enormous influence. The hypothalamus, though weighing only about 4 grams, regulates hunger, thirst, sleep, body temperature, and hormone production. The amygdala, an almond-shaped structure deep in the temporal lobe, plays a crucial role in processing emotions, especially fear. Damage to the amygdala can leave a person unable to recognize fear in others' faces or to experience fear themselves. These small structures, like supermassive black holes, have influence far beyond their size. Galaxies form in clusters, bound together by their mutual gravity. Our Milky Way is part of the local group, a small cluster containing about 80 galaxies, most of them small dwarf galaxies. The local group is itself part of the much larger Virgo supercluster, which contains thousands of galaxies spread across 110 million light-years. And even superclusters cluster together into even larger structures, the filaments and walls that make up the cosmic web. Your brain regions also work in networks. Vision doesn't happen in just one area but involves multiple regions working together. The primary visual cortex processes basic features like edges and motion, while higher areas recognize objects, faces, and places. Memory involves the hippocampus for forming new memories, but also the prefrontal cortex for working memory, the amygdala for emotional memories, and various sensory cortices for the content of memories. These networks communicate constantly, with information flowing between regions in complex patterns. The light from the most distant galaxies we can observe has been traveling for over 13 billion years. These galaxies appear as they were when the universe was very young, less than 1 billion years after the Big Bang. They look different from modern galaxies, smaller, more chaotic, blazing with intense star formation. By observing galaxies at different distances, and therefore different times in cosmic history, astronomers can watch galaxy evolution unfold, seeing how galaxies change over billions of years. Your brain, too, changes dramatically over time. A newborn's brain weighs about 350 grams and contains most of the neurons it will ever have. But the connections between neurons are sparse. Over the first few years of life, the brain undergoes explosive growth in synaptic connections, reaching a peak around age 2 or 3 with about twice as many synapses as an adult brain. Then begins a process called synaptic pruning, where rarely used connections are eliminated. This pruning continues through childhood and adolescence, refining the brain's networks, making them more efficient and specialized. The youngest stars in galaxies are blue giants, massive stars that burn hot and bright but die young, lasting only a few million years before exploding as supernovae. The oldest stars are red dwarfs, small and cool, sipping their fuel so slowly that they can burn for trillions of years. Some red dwarfs will still be shining long after our sun has died, outlasting almost everything else in the universe. Your brain cells also have different lifespans. Some neurons last your entire lifetime, never being replaced. The neurons in your cerebral cortex, the ones that do your thinking, were mostly formed before you were born. But other brain cells are replaced regularly. Glial cells, which support neurons, can regenerate throughout life. And surprisingly, in a few specific regions like the hippocampus, new neurons are born even in adulthood, a process called neurogenesis. These new neurons integrate into existing circuits, contributing to learning and memory. When two galaxies collide and merge, their supermassive black holes eventually sink to the center of the merged galaxy and orbit each other. Over millions of years, they spiral closer together, eventually merging in a cataclysmic event that releases tremendous energy in the form of gravitational waves. These ripples in space-time spread out across the universe at the speed of light, carrying information about the collision to distant observers. When neurons communicate, they also create ripples. The electrical activity of neurons generates electromagnetic fields that can be detected on the scalp as brain waves. Different frequencies of brain waves correspond to different states of consciousness. Beta waves, 13 to 30 Hz, are associated with active, alert thinking. Alpha waves, 8 to 13 Hz, with relaxed wakefulness. Theta waves, 4 to 8 Hz, with light sleep and meditation, and delta waves, 0.5 to 4 Hz, with deep, dreamless sleep. These rhythms reflect the synchronized activity of millions of neurons firing together, creating waves of activity that wash across the brain. The Milky Way is on a collision course not just with Andromeda, but with several smaller galaxies as well. In fact, our galaxy has already consumed dozens of smaller galaxies throughout its history. Astronomers can see the remnants of these ancient mergers, streams of stars stretched out along the orbits of disrupted dwarf galaxies, slowly being absorbed into the Milky Way's structure. Our galaxy has grown through cannibalism, consuming its smaller neighbors over billions of years. Your brain also integrates information from multiple sources, combining inputs to create unified perceptions. When you bite into an apple, your experience of apple is created by your brain combining visual information about its color, tactile information about its texture, olfactory information about its smell, gustatory information about its taste, and even auditory information about the crunch. Each of these sensory modalities is processed in different brain regions, yet they're seamlessly combined into a single, coherent experience. This binding problem, how the brain creates unified experiences from distributed processing, remains one of neuroscience's great mysteries. Galaxies rotate, but not like solid objects. In a rigid disk, the outer edge would move faster than the inner part, like a spinning DVD. But in galaxies, stars at different distances from the center all take about the same time to complete an orbit. This is called differential rotation. The inner regions complete their orbits more quickly in absolute terms, but the outer regions don't lag as far behind as they should based on the visible matter alone. This discrepancy was one of the first hints of dark matter's existence. The dark matter halo provides extra gravity that keeps the outer stars moving faster than they otherwise would. Your brain also has rotational patterns in a metaphorical sense. Attention can be thought of as a spotlight that rotates through different aspects of your experience, highlighting some information while suppressing other information. This attentional focus is not fixed but constantly shifts, controlled by a network involving the parietal and frontal cortices. You can direct your attention voluntarily, but it can also be captured by sudden movements, loud sounds, or emotionally significant stimuli. The balance between voluntary and involuntary attention shapes your conscious experience moment by moment. Quasars are the most luminous objects in the universe, powered by supermassive black holes consuming matter at tremendous rates. The brightest quasars can be 100 trillion times more luminous than our Sun, shining across billions of light years of space. These cosmic lighthouses were most common when the universe was young, between 1 and 3 billion years after the Big Bang. Today, quasars are rare, as most supermassive black holes have exhausted the nearby gas available to feed them and now lie dormant. Certain moments in your life shine more brightly in memory than others. Flashbulb memories are vivid, detailed memories of emotionally significant events, like where you were when you heard important news. These memories feel different from ordinary memories, more vivid and detailed, as if they've been photographically preserved. This vividness comes from the amygdala, which, during emotional arousal, enhances the consolidation of memories in the hippocampus. However, research shows that flashbulb memories, despite feeling more accurate, are just as prone to distortion and error as ordinary memories. The emotional intensity creates confidence, not accuracy. Within galaxies, star formation happens in giant molecular clouds, vast regions of cold gas and dust where gravity overcomes the outward pressure of the gas. These clouds can be hundreds of light years across and contain enough material to form thousands or even millions of stars. Within the clouds, denser regions collapse under their own gravity, fragmenting into smaller clumps that will become individual stars. The process is inefficient. Only a small percentage of the cloud's mass actually ends up in stars. The rest is blown away by radiation and stellar winds from the newly formed stars. Learning in your brain also involves a kind of star formation. When you learn something new, it begins with the strengthening of connections between neurons, a process called long-term potentiation. Neurons that fire together wire together, as the neuroscientist Donald Hebb famously stated. When two neurons are repeatedly active at the same time, the synapse between them becomes stronger, making it easier for signals to pass from one to the other. This synaptic strengthening is the cellular basis of learning and memory. Over time, with repeated activation, the pattern becomes established, just as stars, once formed, continue to burn for millions or billions of years. Supernovae, the explosive deaths of massive stars, are crucial to galaxy evolution. They inject energy into the interstellar medium, creating shock waves that can trigger new star formation or, if they're powerful enough, blow gas out of the galaxy entirely. They also enrich the interstellar medium with heavy elements, making future generations of stars more metal-rich. Without supernovae, galaxies would be very different places, with less dynamic evolution and fewer of the elements necessary for planets and life. Sleep is crucial for brain health in similar ways. During sleep, particularly deep slow-wave sleep, the brain undergoes a kind of maintenance. The glymphatic system, a waste clearance system in the brain, becomes more active during sleep, flushing out metabolic byproducts that accumulate during waking hours. One of these byproducts is beta amyloid, a protein that, when it accumulates, is associated with Alzheimer's disease. Sleep deprivation impairs this clearance process, allowing toxins to build up. Sleep is when the brain cleans itself, preparing for another day of activity. Gravitational lensing occurs when light from a distant galaxy passes by a massive object, like a galaxy cluster, on its way to us. The gravity of the intervening object bends the light, acting like a cosmic magnifying glass. Sometimes this creates multiple images of the same background galaxy, stretched and distorted into arcs or rings around the lensing mass. Einstein predicted this effect, and it's been confirmed thousands of times. Gravitational lensing allows astronomers to study distant galaxies that would otherwise be too faint to observe and to map the distribution of dark matter by its gravitational effects. Your brain also creates distortions and illusions. Visual illusions reveal how your brain processes information, making assumptions and filling in gaps. The blind spot in each eye, where the optic nerve exits the retina, contains no photoreceptors. You should see a gap in your visual field, but you don't. Your brain fills it in with information from surrounding areas. Similarly, your peripheral vision is much less detailed than you think it is. Your brain creates the impression of a detailed, continuous visual field from the sharp central vision of the fovea and much vaguer peripheral information. You're living in a simulation created by your brain, optimized for usefulness rather than accuracy. Spiral galaxies like the Milky Way have distinct spiral arms, bright regions where star formation is particularly active. But these spiral arms are not permanent structures. They're density waves, regions where stars and gas temporarily crowd together, moving through the galactic disk like traffic jams moving through a highway. Individual stars and gas clouds move in and out of the spiral arms as they orbit the galactic center. The arms persist while their contents change. Like a wave on the ocean, the wave moves, but the water mostly stays in place, just moving up and down as the wave passes. Your thoughts also have a wave-like quality. Ideas flow through your consciousness, each thought triggering associations that lead to the next thought. But the underlying neurons don't move, they just fire in sequence, creating patterns of activity that sweep across brain regions. A single thought might involve millions of neurons firing in coordinated patterns, and as one pattern fades, another emerges, creating the continuous stream of consciousness that defines your waking experience. Like spiral arms, thoughts are patterns in activity rather than fixed structures. Dwarf galaxies are the most common type of galaxy in the universe. They contain only millions or billions of stars, compared to hundreds of billions in large galaxies like the Milky Way. Many dwarf galaxies are satellites of larger galaxies, orbiting them like planets orbit stars. The Milky Way has dozens of known satellite galaxies, including the large and small Magellanic Clouds, which are visible from the southern hemisphere. These small galaxies are often stretched and distorted by tidal forces from their larger companions, slowly being torn apart and absorbed. Your thoughts can also be dominated by larger patterns. Mental habits, beliefs, and emotional states exert gravitational pulls on your thinking, drawing thoughts towards certain topics and away from others. Depression, for instance, can be thought of as a thought pattern that pulls all thoughts toward negative interpretations. Cognitive therapy works by helping people recognize these patterns and develop new thought habits, new orbits that lead to healthier mental states. The cosmic microwave background is the afterglow of the Big Bang, radiation that has been traveling through space for 13.8 billion years. It comes from a time when the universe was only 380,000 years old, when it cooled enough for atoms to form and light to travel freely through space for the first time. This ancient light has been stretched by the expansion of the universe from visible light into microwave wavelengths. It's remarkably uniform, the same temperature in all directions to within 1 part in 100,000. But tiny variations in this temperature reveal the seeds of cosmic structure, the density fluctuations that would grow into galaxies and clusters. Your earliest memories also come from a kind of cosmic dawn in your personal history. Most people can't remember anything from before about age 3, a phenomenon called childhood amnesia. This isn't because young children don't form memories. They clearly do, as they learn language, recognize faces, and remember facts. But these early memories seem to fade and become inaccessible. The hippocampus, crucial for forming long-term memories, is still developing during early childhood. Additionally, the massive brain reorganization during early development may overwrite early memories. Your consciousness emerged gradually, with the earliest memories representing the first light that could travel through the developing networks of your infant brain. Stars form in clusters, born together from the same molecular cloud. Open clusters might contain hundreds or thousands of stars, all roughly the same age, formed from the same material. Over time, these clusters disperse as gravitational interactions between stars and encounters with other objects gradually pull the cluster apart. But the stars remain related, siblings born from the same stellar nursery, now scattered across the galaxy. Your autobiographical memories are also clustered. The reminiscence bump refers to the fact that people over age 40 tend to have more memories from their adolescence and early adulthood, ages 10 to 30, than from other periods of their lives. This isn't just because those times were more recent for younger people. Even elderly individuals show this pattern. These formative years, when identity develops and many first experiences occur, seem to be a particularly rich period for memory formation. Like stars born together, these memories share a common origin in a particularly dynamic phase of brain development. The universe is expanding, carrying galaxies away from each other. But this expansion isn't happening within space. Space itself is expanding. Galaxies aren't moving through space away from each other. The space between them is stretching. This is why distant galaxies can appear to recede faster than light without violating relativity, which prohibits objects moving through space faster than light. The expansion of space itself is not limited by this speed limit. Your subjective experience of time also varies. Time seems to pass more quickly as you age, a phenomenon that many people report. One theory suggests this is because each unit of time, a year, a month, represents a smaller fraction of your total life as you get older. Another theory proposes that new experiences require more processing and feel longer, while routine, familiar experiences are processed more efficiently and feel shorter. As life becomes more routine with age, time seems to accelerate. Your perception of time is constructed by your brain and can stretch or compress based on attention, emotion, and novelty. Neutron stars are the collapsed cores of massive stars that exploded as supernovae. They pack about 1.4 times the mass of the Sun into a sphere only about 20 kilometers in diameter, making them incredibly dense. A teaspoon of neutron star material would weigh about 1 billion tons on Earth. Neutron stars spin rapidly, sometimes hundreds of times per second, and have magnetic fields trillions of times stronger than Earth's. Some neutron stars, called pulsars, emit beams of radiation that sweep across space like lighthouse beams. When these beams point toward Earth, we see regular pulses of radio waves, X-rays, or gamma rays, ticking like cosmic clocks with extraordinary precision. Your brain also has its rhythms and cycles. The circadian rhythm, your internal biological clock, runs on a cycle slightly longer than 24 hours, synchronized to the day-night cycle by light exposure. This rhythm affects not just sleep and waking but also body temperature, hormone production, alertness, and even mood. Disruption of circadian rhythms, through shift work or jet lag, can have significant effects on health and cognitive function. Like a pulsar, your brain keeps time, though with less precision. Your circadian clock can drift if not regularly reset by environmental cues. When massive stars die in supernovae, if their core is more than about 3 times the mass of the Sun, even the pressure that supports neutron stars is insufficient. The core collapses completely, forming a black hole. Nothing can stop this collapse. The matter falls into a point of infinite density called a singularity, surrounded by an event horizon, the boundary beyond which nothing can escape. Black holes grow by consuming matter that falls past the event horizon, and they can merge with other black holes, creating larger ones. The supermassive black holes at the centers of galaxies likely grew over billions of years through mergers and by consuming gas, dust, and stars. The brain also has points of no return. Once certain neurodegenerative processes begin, they can be difficult or impossible to stop. In Alzheimer's disease, the accumulation of abnormal proteins triggers a cascade of cellular damage that spreads through the brain. In stroke, when blood flow to part of the brain is interrupted, neurons in that region begin to die within minutes. The brain is resilient, but it has limits, thresholds beyond which damage becomes irreversible. And yet, both galaxies and brains show remarkable ability to persist despite damage. Galaxies can lose large amounts of gas and dust, have their star formation shut down, and still persist as collections of stars orbiting their common center. Your brain can lose regions to stroke or injury and still function, with other areas compensating for the loss. Both systems have redundancy built in, multiple pathways to accomplish similar functions, robustness that allows them to weather damage and change. The cosmic web, the large-scale structure of the universe, extends across billions of light years. Simulations of cosmic structure formation show how this web emerged from tiny density fluctuations in the early universe. Gravity amplified these fluctuations, pulling matter into ever denser regions. The result is a foam-like structure, dense nodes where galaxy clusters form, connected by filaments of galaxies, surrounding vast, nearly empty voids. This structure reflects the initial conditions of the universe and the interplay of gravity, dark matter, and dark energy over billions of years. The social networks that humans create show similar structures. Studies of social networks, how people are connected through friendships, family relationships, and professional associations, reveal patterns that look surprisingly like the cosmic web. There are highly connected hubs, popular individuals, clusters, friend groups, and bridges between clusters. Information, ideas, and even emotions spread through these networks in ways that can be modeled using similar mathematics to those used in cosmology. Your brain exists not in isolation but as part of a larger network of brains, connected through communication and social interaction. Within your individual brain, consciousness itself might be understood as a kind of network property. No single neuron is conscious. Consciousness seems to emerge from the patterns of activity across many neurons, from the integration of information across brain regions. Some theories of consciousness, like integrated information theory, propose that consciousness arises from systems that integrate information in specific ways. The more integrated and differentiated the information processing, the greater the level of consciousness. By this view, your consciousness is not located in any particular place in your brain but emerges from the brain as a whole, from the intricate dance of billions of neurons. In the far future, trillions of years from now, the universe will be a very different place. Star formation will have ended as galaxies exhaust their gas. The remaining stars will age and die. Eventually, only the longest-lived red dwarfs will remain, and even these will eventually burn out. The universe will enter what's called the degenerate era, filled with stellar remnants, white dwarfs, neutron stars, and black holes. Even these will not last forever. Black holes slowly evaporate through Hawking radiation, a quantum process that causes them to emit particles over unimaginably long timescales. A solar mass black hole would take 10 to the power of 67 years to evaporate, far longer than the current age of the universe. But even supermassive black holes will eventually disappear. The universe's far future is one of increasing entropy, darkness, and cold, approaching but never quite reaching perfect uniformity. Your brain, too, has a future, though on incomparably shorter timescales. As you age, some aspects of brain function decline. Processing speed slows, working memory capacity decreases, and the ability to form new memories becomes less efficient. But not all is decline. Vocabulary and general knowledge often continue to increase into old age. Emotional regulation tends to improve, with older adults experiencing emotions more positively and having better control over negative emotions. The brain you have in old age is different from your young brain, specialized in different ways, optimized for different tasks. Yet in the present moment, both cosmos and consciousness are vibrant with activity and possibility. Stars are being born, galaxies are merging, black holes are consuming matter, and gravitational waves are rippling through space-time. In your brain, neurons are firing, synapses are forming and dissolving, neurotransmitters are carrying signals, and new patterns of activity are creating new thoughts, new memories, new experiences. You are, in this moment, the universe experiencing itself. The atoms that form your neurons were created in stars. The forces that allow those neurons to function are the same forces that govern galaxies. The patterns of activity in your brain reflect billions of years of evolution, shaped by the same laws of physics that shape the cosmos. You are not separate from the universe, you are a part of it, a temporary but significant pattern of organization, a brief but brilliant flame of consciousness in the cosmic night. Let this understanding settle into your awareness like cosmic dust settling into nebulae. You are connected to everything that has ever existed, to every star that has ever shone, to every galaxy that wheels through space. The carbon in your cells, the oxygen you breathe, the iron in your blood, all were forged in stellar furnaces. You are made of the universe, and you are the means by which the universe contemplates itself. As sleep approaches now, let your thoughts slow like stars at the edge of a black hole's event horizon, where time itself dilates and stretches. Feel your consciousness settling, your brainwaves shifting from the rapid beta rhythms of active thought to the slower alpha and theta rhythms of relaxation and drowsiness. Your neurons begin to fire in more synchronized patterns, waves of activity washing across your cortex like tides on a cosmic shore. In sleep, your brain will continue its essential work, processing memories, consolidating learning, clearing metabolic waste, preparing for another day of experience. Your consciousness will dim but not disappear entirely, transforming into the strange, symbolic logic of dreams where ordinary rules don't apply and your brain explores possible scenarios, emotional landscapes, creative connections. And the universe will continue its ancient dance. Galaxies will rotate through another minute fraction of their long orbits. Stars will fuse hydrogen into helium, radiating light into space. Black holes will grow imperceptibly. The cosmic web will stretch as space expands. All of this will happen whether you're awake to think about it or not. But while you sleep, you remain a part of this cosmic process, a node in the universal network of cause and effect, a pattern of matter and energy that has temporarily organized itself into the form of a human being with a human brain capable of human consciousness. This pattern will persist for a time, changing and adapting, experiencing and remembering, until eventually it dissolves back into the universe from which it arose. But that dissolution is far in the future. For now, rest in the present, in this moment of existence, this brief flowering of consciousness in the garden of the cosmos. Rest in the knowledge that you are both infinitesimally small and infinitely precious, both a fleeting arrangement of atoms and a unique perspective on existence that has never existed before and will never exist again. From galaxies to brains, from the cosmic web to neural networks, from the Big Bang to this present moment of drowsy peace, all is connected in the great unfolding of the universe. And you are here to witness it, to experience it, to be it. Rest now in your cosmic context. You are the universe dreaming of itself. You are stardust contemplating stars. You are consciousness emerging from matter, awareness arising from physical process, meaning created from chaos. Sleep well, knowing that in sleeping, you participate in one of life's most ancient rhythms. Sleep is universal among animals with nervous systems, from insects to humans. It must serve some essential function, so important that evolution has preserved it despite the vulnerability it creates. In sleep, you join billions of other conscious beings across Earth, all cycling through the same ancient pattern of rest and activity. And perhaps elsewhere in the cosmos, on planets orbiting other stars, in other galaxies scattered across space, other conscious beings are sleeping too, their alien brains processing their alien experiences, their strange forms of consciousness dimming and transforming in sleep just as yours does. You are not alone in the cosmos, even if you are alone in your immediate surroundings. Life, and perhaps consciousness, may be common in the universe, emerging wherever conditions allow, creating countless subjective universes, countless perspectives on existence. These possibilities should comfort rather than diminish you. If consciousness is common, then what you are experiencing, this sense of being, this inner light of awareness, might shine throughout the cosmos, in forms we can barely imagine. The universe might be far richer in experience, in subjective life, than we know. Let these vast thoughts cradle you into sleep. Let the cosmos hold you like a child, for you are a child of stars, born from the death of earlier generations of suns, made possible by billions of years of cosmic evolution, carrying within you the history of the universe from the Big Bang to this present moment. You are ancient and new, vast and intimate, separate and connected. You are a galaxy of neurons creating the inner cosmos of mind. You are matter that has learned to think. You are the universe waking up, looking around, and wondering at its own existence. And now, it's time for the universe, in the form of you, to rest, to sleep, to dream, and to prepare for another day of the grand adventure of consciousness. Sleep deeply, rest peacefully, and know that you are exactly where you belong, doing exactly what you should be doing, being exactly what you are, a temporary but magnificent expression of cosmic creativity, a brief but beautiful arrangement of matter and energy into the form of a living, thinking, feeling being. From the cosmic web to your neural network, from galaxies to your brain, from eternity to this present moment, all is as it should be. Rest now, and let the universe carry you through the night. In the silence of space, energy transforms endlessly from one form to another. Light becomes heat, motion becomes light, matter becomes energy according to Einstein's famous equation, E=mc². The universe is a vast engine of transformation, where nothing is ever truly created or destroyed, only changed from one form into another. The iron in your blood was once the core of a dying star. The calcium in your bones was ejected into space by a supernova explosion. You are not just made from the universe, you are recycled universe. Stellar ashes reformed into living consciousness. Galaxies emit radiation across the entire electromagnetic spectrum. Some shine brightly in visible light, their stars painting portraits across the darkness. Others glow in infrared, revealing warm dust heated by star formation. Still others blaze in X-rays, their hot gas and active black holes radiating high-energy photons. Radio waves emanate from regions where electrons spiral through magnetic fields. Each wavelength tells a different story about the galaxy's contents and activities. To truly see a galaxy, astronomers must observe it in many wavelengths, building up a complete picture from these different perspectives. Your brain also processes information across multiple channels simultaneously. Your senses, vision, hearing, touch, taste, smell, each provide different streams of data about the world. Proprioception tells you where your body is in space. Your vestibular system monitors balance and acceleration. Interoception monitors your internal state, hunger, thirst, pain, the beating of your heart. All of these streams flow into your brain simultaneously, where they're integrated into a coherent model of reality. You experience this integration so seamlessly that you're rarely aware it's happening, but your brain is constantly performing the enormously complex task of synchronizing and combining these diverse information sources. The elements heavier than iron cannot be created in normal stellar fusion. Iron is the end of the line for fusion reactions. Fusing iron actually consumes energy rather than releasing it. So where do heavier elements like gold, platinum, and uranium come from? They're created in the most violent events in the universe, neutron star mergers and certain types of supernovae. When two neutron stars spiral into each other and collide, the tremendous energies in neutron-rich environment allow rapid neutron capture, building up heavy elements. These collisions are rare, but they've happened often enough over cosmic history to see the universe with precious metals. Every gold ring, every platinum catalyst, every uranium atom on Earth was created in such cataclysmic collisions. your memories are also forged in intense moments. While ordinary experiences create ordinary memories, emotionally intense experiences create especially strong memories. This is because stress hormones like cortisol and adrenaline, released during emotionally arousing events, enhance memory consolidation. The amygdala, which processes emotions, has connections to the hippocampus, which forms memories. During emotional arousal, the amygdala essentially tells the hippocampus, "This is important, remember this." This is an evolutionary adaptation. Remembering dangerous or rewarding situations helped our ancestors survive. Your strongest memories, like heavy elements, are forged in intense conditions. The Hubble Space Telescope has revealed that the rate of cosmic expansion is not constant. By observing Type Ia supernovae, exploding white dwarf stars that all have similar peak brightness, astronomers can measure distances to remote galaxies. These measurements reveal that the expansion of the universe is accelerating. This discovery was so surprising that it won the Nobel Prize in 2011. Some unknown form of energy, now called dark energy, is pushing the universe apart. Dark energy makes up about 68% of the universe's total energy content, yet we don't know what it is. It's one of the greatest mysteries in modern physics. Your brain also contains mysteries about its energy use. While the brain uses about 20% of your body's energy, most of that energy isn't used for thinking. Even when your brain seems to be at rest, not engaged in any particular task, it consumes almost as much energy as when you're actively problem-solving or learning. This baseline energy consumption powers what neuroscientists call the default mode network, a set of brain regions that are active when you're not focused on the external world. This network is involved in daydreaming, self-reflection, remembering the past, and imagining the future. The energy your brain uses for this internal mental life, this resting state activity, remains somewhat mysterious, though it appears to be essential for maintaining brain function. Gamma ray bursts are the most energetic explosions in the universe since the Big Bang. These brief flashes of gamma rays, lasting from milliseconds to several minutes, release more energy in seconds than the sun will emit in its entire 10 billion year lifetime. They're thought to be produced by the collapse of massive stars into black holes or by colliding neutron stars. If a gamma ray burst occurred within a few thousand light years of Earth and it's being pointed at us, it could strip away our ozone layer and cause a mass extinction. Fortunately, they're rare in any given galaxy, and most occur in distant galaxies far from our own. Your brain also experiences brief, intense bursts of activity. Epileptic seizures represent storms of synchronized neural firing, waves of activity that sweep across regions of the brain. During a seizure, millions of neurons fire together in abnormal patterns, overwhelming normal brain function. Consciousness can be disrupted, movements can become uncontrolled, and sensations can become distorted. After the seizure passes, the brain gradually returns to its normal patterns of activity. Seizures reveal how delicate the balance is in your brain. Normally, inhibitory signals prevent runaway excitation, but when this balance is disrupted, the results can be dramatic. The rotation curves of galaxies, plots of how fast stars orbit at different distances from the galactic center, provided the strongest evidence for dark matter. According to Newton's laws, stars farther from the center should orbit more slowly, just as outer planets in our solar system orbit more slowly than inner planets. but observations show that stars in the outer regions of galaxies orbit just as fast as those closer in. This can only be explained if there's additional, invisible mass extending far beyond the visible galaxy, a halo of dark matter providing extra gravitational pull. Your brain also has invisible influences on your behavior. Unconscious biases affect your decisions without your awareness. Priming effects demonstrate that exposure to certain stimuli can influence your later behavior in subtle ways. Split-brain patients, whose corpus callosum connecting the two hemispheres has been severed, show that the left hemisphere can confabulate explanations for actions initiated by the right hemisphere, suggesting that much of your conscious reasoning is post hoc rationalization rather than actual decision-making. The conscious you that seems to be in control is influenced by unconscious processes that you cannot directly observe, just as visible matter in galaxies is influenced by invisible dark matter. Tidal forces from gravity can tear objects apart. When an object gets close to a massive body like a black hole, the gravitational pull on its near side is stronger than on its far side. This difference, called a tidal force, stretches the object. If the tidal force is strong enough, it overcomes the object's structural integrity and tears it apart. This is called spaghettification when it happens to objects falling into black holes, as they're stretched into long, thin shapes. Some galaxies have been caught in the act of being tidally disrupted by black holes, their stars stretched into long streams as they spiral to their doom. Stress can have similar tearing effects on your brain and mind. Chronic stress damages the hippocampus, the brain region crucial for forming new memories. Prolonged exposure to stress hormones like cortisol can kill neurons and prevent new ones from forming in the hippocampus. This is why chronic stress is associated with memory problems and difficulty learning. Stress also affects the prefrontal cortex, reducing its ability to regulate emotions and make rational decisions. The amygdala, meanwhile, becomes hyperactive under chronic stress, making you more reactive to threats. These changes can create a vicious cycle where stress makes you less capable of coping with stress. Cosmic rays are high-energy particles, mostly protons, that zip through space at nearly the speed of light. They come from various sources: supernova explosions, active galactic nuclei, even from outside our galaxy. When cosmic rays hit Earth's atmosphere, they create showers of secondary particles. Some of these particles reach the surface, passing through your body as you read this. Every second, about one cosmic ray particle passes through each square centimeter of your body. These particles are energetic enough to damage DNA, potentially causing mutations. Life on Earth is protected from the worst cosmic radiation by our atmosphere and magnetic field, but cosmic rays still contribute to our natural background radiation exposure. Your brain is also constantly bombarded by information, filtering and processing an enormous amount of sensory input every second. Your eyes take in about 10 million bits of information per second, but only about 40 bits per second reach your conscious awareness. The vast majority of sensory information is filtered out, deemed irrelevant by your brain's attention systems. This filtering is essential. If you are consciously aware of every sensation, every sound, every visual detail, you would be overwhelmed. Your brain protects you from this information overload by ruthlessly selecting what enters consciousness, creating the impression of a simpler, more manageable world than actually exists. The interstellar medium, the gas and dust between stars, is not empty but filled with atoms, molecules, and tiny dust grains. In some regions, this medium is extremely hot, heated to millions of degrees by supernova shock waves. In other regions, it's extremely cold, just a few degrees above absolute zero. These cold, dense regions are the molecular clouds where stars form. The interstellar medium is constantly being enriched by dying stars, which return gas and dust to space, and depleted by new star formation, which locks material into stars. This cycle of stellar birth and death has been ongoing for billions of years, gradually enriching the interstellar medium with heavier elements. Your brain similarly cycles materials. Neurotransmitters released into synapses are quickly reabsorbed and recycled. Proteins in neurons are constantly being built up and broken down, with a typical protein lasting only a few days before being replaced. The myelin sheaths that insulate axons, allowing signals to travel faster, are maintained and repaired throughout life. Even though the neurons in your cortex last your entire life, their components are constantly being replaced. The neuron you have today is made of different molecules than the same neuron a month ago. You are, in a biological sense, constantly being rebuilt from the ground up while maintaining continuity of structure and function. The James Webb Space Telescope, launched in 2021, can observe in infrared wavelengths, allowing it to see through dust clouds and observe the most distant galaxies. Because the universe is expanding, light from distant galaxies is stretched to longer, redder wavelengths, a phenomenon called redshift. The most distant galaxies are so redshifted that their visible light has been stretched into the infrared. Webb can see these ancient galaxies as they were just a few 100 million years after the Big Bang, revealing what galaxies looked like in the universe's infancy. These observations show that galaxies formed earlier and evolved faster than previous models predicted. Your earliest experiences similarly shape everything that comes after. The first few years of life are a critical period for brain development. Neural connections form at an explosive rate, shaped by experience. Children raised in language-rich environments develop stronger language areas. Those who experience neglect or abuse show differences in brain structure, particularly in regions involved in emotion regulation and stress response. These early experiences create patterns that can last a lifetime, though neuroplasticity means the brain retains some ability to change even in adulthood. Your adult brain bears the marks of your childhood experiences, just as the present-day universe bears the imprint of conditions in its infancy. Magnetars are neutron stars with magnetic fields 1,000 trillion times stronger than Earth's. These fields are so intense that they warp the very atoms in the neutron star's crust, making the surface incredibly rigid. Occasionally, the magnetic field shifts, causing a star quake, the crust cracks and rearranges. During these events, magnetars emit tremendous bursts of gamma rays and X-rays. A magnetar within 10 light-years of Earth could be dangerous to life, though fortunately, none are that close. Magnetars represent matter in one of its most extreme states, where magnetic forces reshape atomic structure. Your brain structure is also shaped by force, biochemical forces rather than magnetic ones. The growth of axons and dendrites during brain development is guided by chemical gradients and molecular signals. Growth cones at the tips of extending axons follow chemical trails to find their targets, sometimes growing across significant distances within the brain. The synapse formation, The precise connection of one neuron to another requires molecular recognition systems that ensure the right cells connect to each other. The brain's wiring is not random but precisely organized, guided by genetic programs and refined by experience. Exoplanets, planets orbiting stars other than our Sun, number in the thousands, with new ones discovered regularly. These worlds show tremendous diversity: hot Jupiters that orbit closer to their stars than Mercury orbits the Sun, super-Earths larger than our planet, ice giants, rocky worlds, and possibly ocean worlds. Some orbit in their star's habitable zone, where temperatures could allow liquid water to exist. The discovery of exoplanets has revolutionized our understanding of planetary systems and raised the possibility that life might be common in the universe. With billions of stars in our galaxy, many with planets, the cosmos might be teeming with life, even if most of it is microbial. Your microbiome, the trillions of bacteria living in and on your body, represents a kind of ecosystem within you. These microorganisms outnumber your own cells. In your gut, they help digest food, synthesize vitamins, and train your immune system. Surprisingly, gut bacteria can also influence your brain. The gut-brain axis is a bidirectional communication system linking your gastrointestinal tract and your brain. Gut bacteria produce neurotransmitters like serotonin and can affect mood, anxiety, and even cognitive function. You are not just an individual organism but a complex ecosystem, with your brain influenced by organisms that aren't even human. Brown dwarfs are objects too massive to be planets but not massive enough to sustain hydrogen fusion and become stars. They occupy the gap between giant planets and the smallest stars, shining dimly in infrared from the heat of their contraction and from deuterium fusion, which can occur at lower temperatures than hydrogen fusion. These failed stars drift through the galaxy, difficult to detect because they emit so little light. They represent a transition state between planetary and stellar objects, blurring the boundaries we try to draw between different types of cosmic objects. Your mental states also exist on continua rather than as discrete categories. Sleep isn't a single state but progresses through stages, from light sleep to deep sleep to REM sleep, each with distinct brainwave patterns. Consciousness itself might not be an all-or-nothing phenomenon but a spectrum. During general anesthesia, consciousness doesn't simply turn off like a light switch but gradually fades through intermediate states. Some patients report awareness during anesthesia, a disturbing state where consciousness persists but the ability to move or communicate does not. Even the boundary between awake and asleep is not sharp. Microsleeps can occur when you're overtired, brief moments where your brain slips into sleep for just seconds before snapping back to wakefulness. The sun is gradually getting brighter. As hydrogen fuses into helium in the sun's core, the mean molecular weight of the core increases, causing the core to contract and heat up. This makes fusion happen faster, increasing the sun's luminosity. Over the sun's lifetime, its brightness has increased by about 30%, and it will continue to brighten. In about 1 billion years, the sun will be bright enough that Earth's oceans will begin to evaporate, making our planet uninhabitable. In about 5 billion years, the sun will exhaust its core hydrogen and begin fusing hydrogen in a shell around the core, causing it to expand into a red giant that will likely engulf Mercury and Venus and possibly Earth. Your brain also changes over your lifetime, though on much shorter timescales. Cognitive abilities peak at different ages. Processing speed peaks in late adolescence, Working memory in the 20s, vocabulary and general knowledge continue increasing into middle age or beyond. Some abilities decline with age while others improve. Crystallized intelligence, accumulated knowledge and skills, generally remains stable or improves, while fluid intelligence, the ability to solve novel problems, tends to decline. But these are statistical trends. Individual variation is enormous. Some people maintain sharp cognitive function into their 90s, while others experience earlier decline. Gravitational waves carry energy away from accelerating masses. When two black holes orbit each other, they emit gravitational waves, which carry away energy and angular momentum. This causes the black holes to spiral closer together, orbiting faster and emitting stronger gravitational waves. This runaway process ends in a merger, where the two black holes combine into one in a fraction of a second, releasing more energy and gravitational waves than all the stars in the observable universe emit in light during the same time. The LIGO and Virgo detectors have observed dozens of these mergers, opening a new window on the universe. Your brain waves also carry information. The electrical activity of neurons creates electromagnetic fields that extend beyond the brain. While these fields are weak, they can be detected by EEG electrodes on the scalp. Different mental activities produce different patterns of brain waves. Neurofeedback training attempts to help people learn to control their brainwave patterns, potentially helping with conditions like ADHD or anxiety. Brain-computer interfaces read these patterns to allow paralyzed individuals to control robotic limbs or computer cursors with their thoughts. Your mental activity creates detectable physical effects that extend beyond your skull. Clusters of galaxies are the largest gravitationally bound structures in the universe. They can contain hundreds or thousands of galaxies, held together by their mutual gravity. The space between galaxies in a cluster is filled with hot gas, at temperatures of tens of millions of degrees, emitting X-rays. The total mass of this intracluster medium often exceeds the total mass of all the stars in all the galaxies combined. And yet, even all this mass, the galaxies and the hot gas combined, is only a small fraction of the cluster's total mass. The majority is dark matter, forming a vast halo that holds the cluster together. Your brain areas also work in clusters, with different regions specialized for different functions but working together in networks. The frontal lobe handles executive functions like planning and decision-making. The parietal lobe processes sensory information and spatial awareness. The temporal lobe is involved in memory and language comprehension. The occipital lobe processes vision. But these regions don't work in isolation. Complex tasks involve multiple regions communicating through white matter tracts, bundles of axons that connect distant brain areas. Damage to these connections can be just as devastating as damage to the regions themselves, showing that brain function emerges from networks rather than isolated modules. The Fermi paradox asks, if the universe is so vast and old, and if life is likely to arise on many planets, where is everyone? Why haven't we detected any signs of alien civilizations? Various solutions have been proposed. Maybe life is rare, or intelligence is rare, or technological civilizations destroy themselves quickly, or interstellar travel is too difficult, or we're looking in the wrong way, or they're deliberately hiding, or we're among the first. The paradox highlights how much we don't know about the prevalence of life and consciousness in the universe. Perhaps we are alone, or nearly so. Or perhaps the galaxy teems with life, but we lack the technology or understanding to recognize it. The question of other minds is similarly puzzling. You know you're conscious because you experience consciousness directly. But how do you know anyone else is conscious? You infer it from their behavior, from their reports of their experiences, from your recognition that they're physically similar to you. But you can never directly experience another person's consciousness. This is called the problem of other minds in philosophy. Consciousness is inherently private, subjective, accessible only from the inside. Even if we completely understood the neural mechanisms of consciousness, would we understand what it's like to be someone else? Or what it's like to be a bat, a dolphin, an octopus, creatures with very different brains? Consciousness remains deeply mysterious. Voyager 1, launched in 1977, is now in interstellar space, having left the heliosphere, the bubble of particles blown out by the solar wind. It's about 14 billion miles from Earth, traveling at about 38,000 miles per hour. Even at this speed, it would take over 70,000 years to reach the nearest star. Voyager carries the golden record, a collection of sounds and images representing Earth and humanity, a message to any intelligent beings who might find it in the distant future. It's both a scientific instrument and a symbol of human curiosity and our desire to reach beyond our cosmic neighborhood. Your memories also travel forward in time, carrying information from your past into your future. Memories are not perfect recordings but reconstructions, influenced by your current state and subsequent experiences. Each time you remember something, you're not playing back a recording but recreating the memory from fragments stored across different brain regions. This process is subject to distortion. Memories can be altered by suggestion, combined with other memories, or even entirely fabricated. Yet memories are how you maintain continuity of identity across time, how the you of today remains connected to the you of years ago. Without memory, there would be no continuous self, just a series of disconnected present moments. In the last moments before sleep, as your thoughts become more diffuse and dreamlike, as the boundaries between ideas blur and logic becomes loose, you are experiencing the transition between waking consciousness and sleep. Your thalamus, which normally relays sensory information to your cortex, begins to change its pattern of activity. Your cortex becomes less responsive to external stimuli and more focused on internal processing. Your brain waves slow, shifting from beta to alpha to theta frequencies. This transition is a nightly journey you've taken thousands of times, a journey from the external world to the internal landscape of dreams. It's a return to a different state of being, one where your brain processes memories, consolidates learning, and explores possibilities unconstrained by the rules of waking reality. As you make this transition now, remember that you are participating in processes as old as consciousness itself, as fundamental as the rotation of galaxies, as intricate as the cosmic web. You are matter that has learned to think, energy that has become aware, cosmic processes given temporary form and fleeting consciousness. Rest in this knowledge. Rest in your connection to everything that is. Rest in the certainty that the universe that created you continues its ancient dance, indifferent to your sleep but carrying you within it, a small but significant part of the whole. From the smallest subatomic particles to the largest galactic superclusters, from the briefest quantum fluctuation to the entire history of the cosmos, from unconscious matter to conscious mind, all is connected in the great unity of existence. You are here, now, part of this grand unfolding. And that is enough. That has always been enough. Let sleep come gently, like starlight falling on a planet after billions of years of travel. Let consciousness dim like a distant galaxy receding beyond the cosmic horizon. Let your thoughts slow like the gradual cooling of the universe itself. You are the cosmos, resting. You are the universe, dreaming. Sleep deeply, consciousness. Sleep well, stardust. Sleep peacefully, child of stars and time and the vast mysterious universe that continues always, carrying you within it.